Here we go. All right, Algebra 1 video on section 1.3 from the textbook. So big ideas 1.3. This is solving linear equations with variables on both sides of the equal sign. So our goals today are to identify the number of solutions an equation has. It could have one solution, no solutions, or infinitely many solutions for a linear equation. And we're going to solve an equation with variables on both sides of the equal sign. So let's go ahead and jump in. We're going to do a couple examples, talk about them, do a few more examples, talk about them, summarize, and then there will be some time for you to try some and then check your work. All right, so let's say we have an equation like this. 10 minus 4x equals negative 9x. We want to solve this. Notice there's a minus 4x on the left side of the equal sign. There's a minus or negative 9x on the right side of the equal sign. In general, what we want to do is we want to have the variable on one side. Our goal, the goal is x equals something, right? And if we have x's on both sides of the equal sign, well, we don't want x equals something with another x. We want x equals a number. So what we're going to do here is we're going to get x to one side of the equal sign by doing the opposite of one of the x terms. So we got two options here. We could go the opposite of the minus 4x, which would be add 4x to both sides. All right, I'm going to write it here. We can do it either way. Or I could add 9x to each side. These are both acceptable things to do. These are like the two things you would want to do. So on this one, I've got 10 equals, because the minus 4x and the plus 4x cancel out, equals negative 5x. So here, we have gotten a regular number on the left. We have the term with the variable on the right. We've got a negative 5 in front of it, which is fine. If you really don't like negatives, you could go this route and get rid of the negative 9x by adding 9x to each side. And then here, you would get 10 plus 5x equals 0. And make sure here you get 0. It's negative 9x plus 9x. Sometimes Algebra 1 students have a tendency just to do this, and then it just kind of gets lost because that equal sign goes away. All right, so now for this one, if you have 10 equals negative 5x, remember, this negative 5x is negative 5 times x, so what you would do is you would divide by negative 5, right? Because you're undoing the multiply by negative 5. You do not add 5 to both sides on this case. You divide by negative 5 to undo the multiplication by negative 5. So here we get negative 2 equals x, and that's our answer there. This one, we've got a couple more steps, but we don't have to deal with that negative 5x. Right, we're going to get rid of the 10 by subtracting 10 on each side. We'll get 5x equals negative 10. And then we would divide by 5. Divide by 5, divide by 5. And it gives us the same answer, x equals negative 2. So basically, if you see a variable on both sides of the equal sign, what you want to do is make it so that you've got variable, or the x, only on one side of the equal sign by doing the opposite of one of these things. We did the opposite of the 4x, or the minus 4x here by adding 4x to each side. That worked. Or we could have done the opposite of the negative 9x by adding 9x to each side. And that also worked. It just took an extra step, but we didn't have to deal with the negative in front of the x. Either one works. Sorry, they both work. All right, and notice on this one, I was getting rid of the negative 9x off of the right. I was trying to move or to make that into a 0. So I added 9x. With this negative 5x, I've got the x all by itself now. There's no other x's out here. So I divided by the negative 5 to undo the negative 5. Those are different things here. Okay. And remember, you can always contact me during my office hours or send me an email if you got questions about what we're going over, what I'm going over here in these videos. Or homework questions, or, basically I'm open for your questions, so please ask them. Yeah. All right, let's do another example. So here we have 3 times 3x minus 4 equals 1/4 times 32x plus 56. What I want you to do when you think to yourself, what do you think a good first step would be? Go ahead, just say it to your computer. Well, there's a couple good first steps. One, what we could do is we could distribute the 3 and distribute the 1/4 to get rid of those parentheses. That's the first step I would take, probably. Another thing you could do is you could multiply. Oh, we'll just distribute. We can save that other stuff for later. So basically, I want to get rid of these parentheses here, so I'm going to distribute through the parentheses. Right, so basically we're simplifying each expression, so each side of the equal sign. We're going to simplify it first, and then we'll get x's on one side of the equal sign, numbers on the other, and solve. Alright, so here I have 9x minus 12, notice there's a subtraction here, subtraction there, equals, now when I'm multiplying 1/4 times 32, 1/4 times 32, anytime you're multiplying a fraction by any other number, remember this, a fraction is a division problem in disguise. The top number is a multiply number, the bottom number is a divide by number, because this is 1/4, it's 1 divided by 4. So what I'm going to do is I'm going to go 32 times 1 is 32, and then 32 divided by 4 is 8. So this gives me 8x. Right, so I have 1/4 times 32x. And then here I'm going to go plus, because there's addition there. And once again, I'm going to go 56 times 1 is 56. 56 divided by 4 is 14. All right, so I've gotten rid of the parentheses. In other words, I've simplified both sides of the equation. Now what I want to do is get variable on one side, regular numbers on the other. So I look at it, and there's a 9x and an 8x, right? See that? So we could either subtract 9x on both sides and get the x's off the left, or I could subtract 8x from each side and get the x's off of the right. Which one do you think is going to be a better option? Just say it out loud. All right, hopefully you went with subtract 8x. And the reason to subtract 8x is so that we're left with a positive 1x, and positive numbers are just easier to work with than negative numbers. So here we have x minus 12 equals 14, and then I'm going to add 12 to both sides to get rid of this minus 12 here, and that gives me x equals 26. And that's my final answer. Cool. All right, so basically what we have here is if you have like parentheses or like terms or that sort of thing, simplify each expression, so each side of the equation. So simplify, simplify. And then once you have something with just variables on both sides, undo or do the opposite of one of the variables to make it so that there's no more variable on that side. So basically you only have an x or only a variable on one side of the equal sign. Then you can solve the equation like you would a normal equation. Right? Remember, the goal is x equals number, not x equals something else with an x in it. If you ever end up with x equals something else with an x in it, you got more work to do. All right, here we go. We're gonna try a couple more problems. I want you just on your notes, your paper, because you are taking notes with this, right? I hope so. Try these two problems. So we've got 3 times 5x plus 2 equals 15x, and then we have negative 2 times 4y plus 1 equals negative 8y minus 2. Go ahead and try these two problems. So pause the video, try them, and then I'll go over them and we can talk about it. Well, I'll talk about it, you listen, you pretend that you're talking back. Go. Alright, hopefully you paused the video, we're back. Now, notice these have variables on both sides. So step one, whenever there's variables on both sides, is we want to simplify anything that we can simplify. So what I'm going to do is I'm just going to distribute this 3. You could have divided both sides by 3, that would be acceptable as well. But we're just going to distribute because it's something we're practicing in this class. So here we have 15x plus 6, because 3 times 5 is 15, 3 times 2 is 6, and addition stays addition, equals 15x. All right, so now we have variable on both sides, what we want to do is make it so that there's not a variable on both sides. So we're going to do the opposite of the 15x by going minus 15x. Right? We're just like going right through this process, this algorithm. So 6 equals 0. We're like, what? 6 equals 0? That's not right. There's no more variables. And we get like 6 equals. Does 6 equal 0? Are those the same number? Right? Absolutely not. They're not the same number. So what we do in this case is we say no solutions. There is no solution to this equation, and the reason for that is because this expression here is 6 larger than this expression here, right? This expression is 15x, this expression is 15x plus 6. So no matter what number you put in for x, this answer is always going to be 6 bigger than this one. So they will never be equal, because remember, this symbol right here means they're the same value. And with this symbol and this being, and this side being 6 more than that side, it just can't work. There's no number you can put in for x to make that equation actually equal on both sides. Okay, so in that case, where one side of the equation, one expression, is larger than the other, like necessarily larger, like there's nothing you can put in, there's nothing else you can do, you say no solution. And the way that you can be sure of that is go all the way through the solving process. Right? We simplified, we got it so that, we undid one of the x terms, the terms with the variable, right, by minus 15x, and we got no more variables, right? No more variables. See how there's no more variables? And we get number equals different number. That's when we say no solution. 6 equals 0 is a false statement. 6 does not equal 0. So there's no solution. All right, let's move over to this one. So here we have negative 2 times 4x plus 1 equals negative 8y. Or sorry, that's a 4y, I said x, y. Negative 8y minus 2. So what we're going to do is we're going to simplify. It's first step, simplify. So we're just going to distribute this negative 2. And that's going to give us negative 8y minus 2 equals negative 8y minus 2. And some of you might just be like, woohoo, look, that's true, right? Negative 8y minus 2 is 100% equal to negative 8y minus 2. They're the same thing, right? And if you're ever like a little shaky on this, what you can do is you can just do that next step like we did here. You say, well, let's get it so that we get rid of the one of the things with the, one of the terms with the variable in it. So we'll just do the opposite of a negative 8y, which is plus 8y. We do that to each side, and negative 8 and 8 make that. Negative 8 and 8 make 0. So we have 0 minus 2, which is negative 2. Negative 8 plus 8 is 0, so 0 minus 2 is negative 2. And here we get no more variables, and negative 2 equals negative 2. So number equals the same number here, right? So in this case, and we see this earlier on, right? This negative 8y minus 2 is equal to itself, negative 8y minus 2. We call that an identity, where no matter what number you put in for y, it's gonna work. So what we say here, there's a couple things you can say. You could say any real number, or all real numbers. We're gonna use the terminology that the textbook uses because you're using the textbook for your homework. So we're gonna say infinitely many solutions. It's a little bit of, it's not as specific as it should be, but that's what the textbook uses, so that's what you're going to need to put in for your homework to get the right answer for the homework. Any real number would actually be the better answer because you can put in any number for y and get the right answer. Infinitely many just means like there are infinitely many numbers larger than 1, but we can still put in any negative number and it still works. So don't worry about that. Basically, Just know that if you get number equals number, you say infinitely many solutions. All right, let's do a little bit of a recap of how do we know if there are infinitely many solutions. Well, looking at this example, basically we had the exact same thing on each side of the equal sign after we simplified, right? Here it wasn't quite as clear. Maybe you saw it if you did this step in your head, but once you simplified, like these are exactly the same. And then to be certain, we add that 8y and we get number equals same number. So here there are no more variables. And we get number equals same number. That's when we get infinitely many solutions. If you do the solving process, right, simplify both sides, do the opposite of one of the variable terms so that you have variable only on one side now. But if the variables cancel out, they both go to 0 like this did, and you get number equals same number, then you say there are infinitely many solutions, because there are infinitely many solutions. Now, we get no solutions in a case like this, where we simplify both sides, and we get the exact same thing with the variables, but different numbers, like this is 6 larger than this one. And a way to be really, really sure that there are no solutions is do the opposite of one of the terms with the variable in it. So minus 15x minus 15x, so those both go to 0, and now we have 6 equals 0, which is not true. You get a statement with no variables, and it's a false statement. It's not true. 6 does not equal 0, so we say there are no solutions. All right, now you might be asking, like, well, we can have one solution, right? Yeah, you get one solution when you do a problem like this. Or like you simplify, or you get the variable on one side, you solve, and you get variable equals number. So in other words, if there's still a variable, like an x equals at the end, there's one solution for a linear equation. We'll deal with quadratics and that sort of thing later, where they can have 2 answers. 2 solutions. But here, linear, we're talking about linear equations like this, just regular x's, or regular linear variables. If you get x equals or variable equals number, there's only one solution. Okay, so I'm going to write up 3 problems. I want you to pause the video, try them, identify what the solutions are and how many solutions, what the solution is or how many. So if there's no solution, just say no solution. If there's infinitely many solutions, say infinitely many. If there is one solution, tell me what that solution is, please. All right, so I'm going to write up these 3 problems, and I want you to work on them before I do them. That's how you learn, is by like doing it, and if you make a mistake, you can then learn from your mistake. So we have 21 minus 7w equals 7 times 3 minus w. That's problem 1. So go ahead and do problem 1 while I write up problems 2 and 3. So problem 2, we have 4 times, oh my goodness, problem 2, 4 times 3 minus m equals 1/2 times 24 minus 8m. So if you finish the first one, try the second one. If you haven't finished the first one, keep working on it. All right, problem 3, we have 8 times x plus 1 equals, oh my goodness, 8 times x plus 1 minus 8x, sorry, equals -8. All right, let's go ahead and run through this. Actually, sorry, if you haven't done so yet, pause the video now that these 3 problems are up. Pause the video, write the problems down, do the 3 problems, and then compare your answers with what I get here. Okay, so I'll give you a moment. Hopefully you paused it, and we're going to go over them now. Okay. So for this problem, problem 1, this is simplified as far as I can go. Here we have 7 times, well, 3 minus w. So what we're going to do is we're going to distribute the 7. We're going to simplify the right side of the equation. So now I have 21 minus 7w equals 21 minus 7w. And we're like, hey, yeah, that's true, right? These are exactly the same. So you could just jump to saying infinitely many solutions, right? And then if you're not quite sure, you're like, I don't know yet. What you can do is you can always do the opposite of, because we have variables on both sides, we'll do the opposite of one of the terms. So plus 7w, it's the opposite of minus 7, it's plus 7, plus 7w, right? That makes this go to 0, that makes that go to 0, and we get 21 equals 21. Number equals same number, equals itself. So our answer, the answer, is infinitely many solutions. Notice, the answer is not 21 equals 21. That's the work that leads us to the answer, which is infinitely many solutions. Saying, you can put any number in here for w, and it'll still, like this side, this expression will equal this expression, regardless of what number you put in for w. Okay. Let's look at problem 2. So problem 2, both sides, or sorry, neither side is simplified. They both have the parentheses, right? So what we're going to do is we're going to distribute. So we get 12 minus 4m equals, and distribute, right? And the way I got 12, 4 times 3 is 12, 4 times m is 4m. The subtraction stays. Now I'm going to go a half times 24. Remember, when we're multiplying a fraction, it's this number times the top number times the numerator, so 24 times 1, and then divided by the bottom number. That bottom number in a fraction is a divide by number. So 24 times 1 is 24, 24 divided by 2 is 12. So here I get 12 minus, and then 8 times a half is 4, minus 4m. Oops. That's not what I meant to write. I think I goofed on writing this problem down. I'm sorry, it was supposed to be a plus. Eek. The way I wrote it, you would get no solutions. Or you get infinitely many. Sorry, I goofed. I even had it right here, written as 24 plus 8m, and I wrote it down wrong. So go ahead and turn that into a plus. Sorry, my bad. Sorry, I'm not going to take time to edit this out either, because I'm not like a computer YouTube wizard. I'm just let's do one take and call it good. All right, so going back, let's say this was the actual problem. 4 times 3 minus m equals 1/2 times 24 plus 8m, right? So I distribute 12 minus 4m, and then distribute a half times 24 is 12, a half times a positive plus 8m is a plus 4m. Okay, and let's pretend that error never happened. Sorry. So we look at this, and we're like, all right. I mean, it looks the same, right? There's 4m, 12, and 12, but here there's a minus, and here there's a plus. So they're not exactly the same. So what we're going to do is we're going to do the opposite of one of the variable terms to see what happens. So here it's a minus 4m, so I'm going to add 4m to both sides. So plus 4m plus 4m. And now I have 12 equals 12. And then 4 plus 4 is going to give me actually 8m. The variables don't cancel out here, even though it kind of looks like they do because they're both 4m's, but one's a plus and one's a minus. What I've seen from students sometimes is they'll see this and they'll just combine them to make 0. It's like minus 4 plus 4 is 0, but they're on opposite sides of the equal sign, so we can't do that. We have to do the opposite of this to go to the other side of the equal sign, basically. Okay? All right, it's probably confusing. Sorry, that was poorly worded. So now I'm just going to solve this normally. So I go minus 12 to undo what's happening to the 8m, or to the m over here. 12 minus 12 is 0, equals 8m, right? This 8m is 8 times m, so we got to undo that multiplication. So I'm going to divide by 8, divide by 8. I get 0 divided by 8 is 0, so 0 equals m is our answer. It's not no solution because the answer, because we get a 0. It's one solution because 0 is a number. So if m is 0 here, both sides of the equation, or both expressions, are equal. And once again, sorry for writing that typo as a minus. It was supposed to be a plus. So If it was a minus, it would have been infinitely many solutions. All right, let's jump to the last one here. Here it's 8 times x plus 1 minus 8x equals negative 8. Right, this side is not simplified, so what we're going to do is we're just going to simplify it. We're going to distribute the 8. So we get 8x. Notice we don't multiply the 8 over here because the parentheses stop after the 1. So here I have 8x plus 8 minus 8x equals negative 8. Now I'm going to continue simplifying. I've got variables, but they're on the same side. So if we have variables on the same side of the equal sign, remember we do what? Combine like terms. I have 8x minus 8x. 8 minus 8 is 0. So I have 0 x's, which basically just cancels out. So I have 8, positive 8, equals negative 8. Is that true? Is 8 equal to negative 8? I know I can't hear you, but I'm pretending anyway. No, it's not equal, right? 8 is not equal to negative 8. So we got number equals different number, no more variables, so we write no solutions. Or just no solution. We don't have to say no solutions, we can just say no solution. All right, that is that. So, once again, you should be able to do the Big Ideas Math 1.3 homework now after watching this video. If you have any questions, just find me during asynchronous time. Mondays and Thursdays, it's after school. Tuesday, Fridays, it's before school. And just feel free to email me if I'm on my computer and I have time. I'll send you an email back. All right, have a wonderful day and hope this was helpful.